When the direct relationship between two variables x and y is awkward to analyze, it may be easier to express x and y in terms of a third variable. This third variable is known as a parameter. For example, y equal to the square root of x minus 1 is a Cartesian equation, as y is written directly in terms of x. X equal t squared and y equal t minus 1. Both x and y are written in terms of a third variable, and this is known as a parametric equation. To convert from parametric to Cartesian, first we use one of the equations to make t the subject, then we plug the expression for t into the other equation. That's it. Soft.
We're going through Cartesian equation and parametric equation. As we know, Cartesian equation is typical equations that we're used to seeing y written as a function of x. Now, sometimes you're given parametric equation where x and y are defined in terms of a parameter, and we need to make y the subject. So this one says, determine the Cartesian equation of this curve. In order to do that, we need to eliminate the parameter. So in order to do that, what we're going to have to start with is, well, this one has cos and this has sine. But guess what we do know? We do know that sine squared theta plus cos squared theta, we know that sine squared plus cos squared, that is equal to 1. Sine squared plus cos squared is equal to 1. This is what we know. So since this is what we know, then what we need to do is make cos theta the subject on this side, sine theta the subject on this side, square both of them and add it. So let's do that. From this right here, from this one right here, we can extrapolate that x minus 2 divided by 3, that would be equal to cos theta, if we make cos theta the subject from that side. So cosine theta is x minus 2 over 3. Now let's look at this side right now. To make sine theta the subject from that side, we would get y minus 2 being divided by, that looks like 5. And that would be equal to the sine of our angle, which is the sine of theta. Now we know that sine squared plus cos squared is equal to 1. So since sine squared plus cos squared is equal to 1, we're going to plug in cos theta as x minus 2 over 3 in this formula. We're going to plug in y minus 2 over 5 in this formula. So what we're going to get is y minus 2 over 5. This is all squared. It is all being squared, plus cos square theta, where this is cos theta is x minus 2 over 3. So it is x minus 2 being divided by 3. And this is all being squared. And we know this is equal to 1. Now what do we do now? Well, you can expand and simplify this. So let's square this now. If we're to expand this part, it would become y minus 2. All I'm doing is just expanding the numerator, expanding the denominator, I should say, y minus 2 squared over 5 squared, which is 25, plus this side now would just be x minus 2 all square over 3 square, and 3 square is 9, is over 9, and this is equal to 1. So this is the Cartesian equation. So this is the Cartesian equation. All right. Oftentimes they try to write y in terms of x, but nothing is wrong with leaving it this way. So that is the Cartesian equation. Easy, soft. That's how we find the Cartesian equation of this example. Let us try another one. This question says a curve has parametric equation x equal cos t and y equal 3 plus 2 cos 2t. Show that the Cartesian equation of the curve is in the form y equal ax squared plus b, where a and b are constants. First thing it tells us is that x is cos t and y is 3 plus 2 cos 2t. Now, first thing is, look right here, cos 2t, there's an identity for cos 2t that we must know. That identity is that the cos of 2t, we must know this identity, cos of 2t is equal to 2 cos squared t, 2 cos squared t minus 1. That's the identity for cos 2t. Cos 2t is 2 cos squared t minus 1. And so what that means is that, remember, cos x is cos t. X is cos t. And so cos 2t is actually 2 cos squared t, but cos squared t would be x squared. So cos 2t is actually 2x squared minus 1. This is what is actually cos 2t. Cos 2t is actually 2x squared minus 1. Again, why is it that? Because if x is cos t, then x squared is cos squared t. X squared must be equal to cos squared t. And if x squared is cos squared t, we can replace x squared. We can replace x squared with cos squared t. Replace the cos squared t with x squared. So cos 2t is 2x squared minus 1. So that implies that y is going to be equal to, y is now going to be equal to 3. Y is equal to 3 plus 2 cos 2t, which is now 2 times cos 2t, but this is cos 2t. Cos 2t is now given by this formula. Cos 2t is 2x squared minus 1. So in this bracket, it's now going to be 2x squared minus 1. And so what we're ending up getting is, if you expand this bracket and simplify, we end up get 3 plus 2 times 2 is 4. So we get 3 plus 4x squared minus 2, and that is y. And so what we end up getting is y is equal to 4x squared, and then your 3 and your 2, remember, positive 3 minus 2, that leaves plus 1. So y is equal to 4x squared plus 1. So just to put this is then your Cartesian equation. So see it there, it is in the form y equal ax squared plus b. Comparing it to that form, you could actually conclude that, hence, in this case, a equal 4 and b is equal to 1. A equal 4 and b is equal to 1. And that's that right there. Easy question. Let's look at another one now. This one now, find the Cartesian equation of the following. Parametric equation, x equal 1 over t minus 2, y equal 4t plus 5. Now if x is 1 over t minus 2, Then you can swap t minus 2 and x, and you would get that t minus 2 is equal to 1 over x. And then you can just add 2 to both sides to get t would end up be equal to 1 over x plus 2. That is t, 1 over x plus 2. Then what you're going to do is substitute t equal 1 over x plus 2 into y. So you sub t into y now. Sub t into y. That's what we do. We sub t into y. So let's go ahead and sub t into y. So we sub t equal 1 over x plus 2 into y. Have to write that down. All right, so let's go ahead now. So what we're going to get now is y is going to be equal to 4 times t, where t is 1 over x. So it's 4 times 1 over x plus 2. And then we add 5 to it, plus 5. That's what we do. So what we're going to get for y is 4 over x. And then we have 4 times 2, that is 8. So that is plus 8 plus 5. But 8 plus 5 is 13. So in reality, what we're getting is y is working out to be, so y is working out to be 4 over x plus 13. That is y. Y is 4 over x plus 13. Some people might like to write it this way, or it's always good to write an alternate, or you could leave it as y is equal to, this is now 4 plus 13x over x. Some people like to write it as one fraction together. So it would be 4 plus 13x over x. So if you like to write it as one fraction, this is how you'd leave your solution. That's for this question. Nice and easy, soft. Let's look at another example. This example here says x is equal to 6 minus t and y is equal to the square root of 3t minus 4. X is equal to 6 minus t and y is equal to the square root of 3t minus 4. Find the Cartesian equation from this. So first we make t the subject from this one. So what we get is t is equal to 6 minus x. All right, from this one right here, we get t is equal to 6 minus x. Then we're going to plug t into this equation right here. And so we sub t into y. So that implies now subbing t into y, we're getting y is equal to, just to write your statement, what we do, we sub t equal to 6 minus x into y. So if you want to write that out, so what we're getting is y is now the square root of 3 times t, but t is 6 minus x, and then we subtract 4. So that's what we get. That is y. So just to do that now, what we get is y is equal to the square root of 3 times 6 is 18, so we get 18 minus 3x minus 4. And if you want, you can leave it prettier to just write that y is equal to the square root of 18 minus 4. 18 minus 4 is 14. So we'll get 14 minus 3x. That would be y. The square root of 14 minus 3x. And this would be the Cartesian equation. Y in terms of x again. All right. So that is the Cartesian equation. Easy question. So let's go ahead now and go again. So this one now says x is equal to 4 sec t and y is equal to 3 tan t. Now we have to remember an identity from trigonometry. The identity from trigonometry that we must know is that tan square t plus 1 is equal to sec square t. That's the identity that we're going to need to recall in order to do this question. This is a trigonometric identity that we must know. Tan square t plus 1 is sec square t. So now we have y is 3 tan t. So if I make tan t the subject there, I would be getting that y over 3 is equal to tan t. That's what I'm getting from that side. And if I were to make sec t the subject right there, then I would be getting that x over 4 is equal to sec t. X over 4 is equal to sec t. All right, so this is what I'm getting. X over 4 is equal to sec t. Now what does that do for me? If I square both sides, then what I'd be getting is y square over 3 square, which is 9, is equal to tan square t. So y square over 9 is equal to tan square t. And also over this side, if I square both sides, I get x square over 4 square is 16. So x square over 16 is equal to sec square t. That is now sec square t. So then now what do I do? Well, what I do now is plug in this formula up here. Tan square plus 1 is sec square, but tan square is y over 9. So that implies that plugging in tan square as y square over 9, we get y square over 9, y square over 9 plus 1 is equal to sec square, but sec square is x square over 16. X square over 16. From here on, you could continue to make y the subject if you may. So first we can multiply through by 9 if you want. You can multiply through by 9 to get that y square. You can multiply through by 9 to get y square plus 9 is equal to, that look like 9x squared over 16. And then we can subtract 9 from both sides to end up get that y square works out to be equal to, that is now 9x squared over 16, 9x squared over 16 minus 9, that is y squared. Now if you want, you can just square root both sides to leave it as y is the square root of 9x squared over 16 minus 9. This would be your Cartesian equation for this question. That's your Cartesian equation. No problem. Let's look at another example. And let us look at this example here now. X is equal to cos t and y is equal to 2 sine square t. Now, there's an identity that we know in terms of sine and cos. All right. So x is cos t and y is 2 sine square t. But guess what? We can rewrite y then as sine square t. Sine square t is 1 minus cos square t. So y is 2 times 1 minus cos square t. But what do we know? We know that the cos of t is x, and so y works out to be equal to 2 times cos square t. Cos t is x. This is 1 minus x squared. 1 minus x squared. And so that means y work out to be 2 minus 2x squared. 2 minus 2x squared. That is it for converting from parametric to Cartesian. It's very simple. All you need to do is eliminate the parameter, and that's it. I hope that you had just as much fun as I did, and so stay tuned for more. All the best prepping for your classwork and your exams.